All right, we have finally reached the end of Unit 2. So here we are at the Unit 2 review. Let's get started. Most of these I've drawn a picture for or tried to get something semi-accurate, but not all of them. So we'll get through them though and answer in as many questions as we can. So question 1, 20-foot pole, that's the blue line, is leaned up against a wall that reaches 18 feet above the ground. So therefore your two sides respectively. It's asking for the angle the pole makes with the ground. So that's where we've got green, and I use alpha in this case as the variable for the angle. So as long as we have our picture accurate, we can start looking at what trig function can we use that associates those three things. So angle alpha, the side opposite of that, and the hypotenuse. And when we look into that, we realize that the angle that uses opposite hypotenuse is sine. So sine of alpha is that ratio of opposite over hypotenuse. And we need alpha by itself. So to undo sine of alpha, just like we have done always in the past, to undo something like 2x, we undo the multiplying by dividing by 2. Here we take the sine inverse of sine. And what we do to the left side, we do to the right. So if we divide it by 2 on the left, we divide it by 2 on the right. So we take the sine inverse of both sides. And again, the undoing of sine inverse of sine of alpha, that just leaves us with alpha. And over here on the right, this sine inverse 18/20ths, that will give us an angle. So let's get our calculator. There. And first thing we always check, just at least when we get started for the day, we want to make sure we're in that right mode. So here we are in degrees mode. So we second mode. And we said we need to take sine inverse. So second sine key gets us that sine inverse of 18/20. Hit enter, and we know that we're in degrees mode, so that gives us the answer 64.16. Degrees, we box that in because we've checked, and it's saying what angle does this make. We're at the right angle, alpha, and we are good to go. So box it in, move on. Next one, when a plane had flown 4,150, I don't know, meters, miles, inches, I don't know. It's flown 4,150 from the airport though, where it taken off from. By that time, it had covered a horizontal distance of 3,660. So what it's trying to say, it's a little tricky to get to, but if you start drawing the picture out, horizontal 3,660, so we know that. The 4,150, that was a little bit more confusing to some people, myself included, but by deductive reasoning, I'm going to say that it is that hypotenuse distance. It says, what angle does the plane, what is the angle the plane rose from the ground? Okay, that's just a weird way of saying it, but we're asking for this angle right here. Again, I use alpha. It's easier on my touch screen to draw that than it is to draw the theta symbol. So we're trying to find that angle in question 2. H we don't know, but we also don't care. So not that we don't care, we just don't need that information for the problem. So here we have an angle. This time we don't have the opposite in the hypotenuse. We have the adjacent side, the side next to the angle, as well as the hypotenuse. So this one, we're going to, I'll keep it a little darker, so we're going to use cosine of alpha. Again, we don't know the angle, but we know that the ratio is 3,660 over hypotenuse. What we do to one side, we do to the other, so we're going to take the cosine inverse. We say alpha is equal to the cosine inverse of that ratio. And alpha ends up being approximately 28 0.12 degrees. Okay, make sure your calculator's in the right mode. You get the right ratios, all that good stuff. But that should be your answer for number 2. Number 3, boy visiting Chicago views the Willis Tower from a point on the ground. So there's the boy's on the ground looking up at this blue line is his line of sight. A tower, and we know that the boy is standing 1,240 feet from the base, so that's that horizontal distance. We also know the angle of elevation, so that's like from horizontal. If the boy was to be looking horizontal and then look up at the top of the building, that's 49 degrees. They're asking for the height of the building. There's the h variable. So in this case, we know the angle, we know the adjacent side, we don't know the opposite side. So the ratio that we use to solve a trig function with the opposite and adjacent sides, that's the tangent ratio. So we're going to spell that one out. Tan of the angle, in this case 49, is equal to our unknown h opposite over the adjacent 1240. Now to get h by itself, we multiply, real quick, I'll change it to red. Multiply by 1240 on both sides. 1240 times both sides, we get h equal to, and then if you just type in 1240 times tan 49, again making sure you're in degrees mode, you find that the h is 1,426 point, I believe it's about 46 feet. Check the realism of that. If you think about it, a 49 degree angle, if it was 45 degrees, we could have done this without any math. We just know that 1240 and the height would be also 1240. Because our angle is a little bit taller than that, we know that that height must be a little bit bigger than 1240, and it is 1,426. We've answered the question at hand. What is the height of the building? We are good to roll again. So let's do one more here. A buoy in the ocean observed from the top of a 40 meter radar tower. So there's my wonderful drawing of a radar tower along the shore, little red buoy standing out here. This is one that I know people had trouble with in our CFA and during the unit. The angle of depression. So the angle of depression from the top of the tower means you're going to, instead of looking straight horizontally, you're going to start to look down at an object. That angle from horizontal down is what I've labeled as 6.5 degrees of the angle of depression. So we've labeled 40 meters, the height of the tower, and the angle of depression 6.5 degrees. That is asking for x, how far is the buoy from the base of the tower. So there's my green, I'm looking for green. So what we're going to do with this is we can't use 6.5 here exactly because it's not part of this triangle for which I have the opposite and adjacent sides. But what I do know is that if 6.5 degrees is my angle of depression from the tower, that means that I also have an angle of elevation from the buoy exactly equal to that 6.5 degrees. It looks like 65. Okay, so now I have the angle 6.5, the opposite 40, and the adjacent x. So I'm going to write out my ratio of tangent of my angle is equal to 40 over x. Now I'm going to multiply both sides by x, and I get that. Now I still want x by itself. I'm going to divide both sides by the tangent 6.5. And I get x is equal to 40 divided by a tangent of 6.5. So my x distance, the number I'm looking for, if I plug in my calculator, 40 over tan 6.5, making sure I'm still in degrees mode, there's no reason I shouldn't be, then my number is 351.08. My units were meters, so make sure I have an answer of meters in there. But there you go. That's questions 1 through 4. On that Unit 2 review, we've got our answer for number 4. So we'll stop here and we'll pick up with question 5 in the next video.